Hello everyone. So in this video, we will be discussing deferred annuity. So deferred annuity is a type of annuity where the first payment is made several periods after the beginning of annuity. And it is given by the formula P is equivalent to A over I times 1 plus I raised to N minus 1 all over 1 plus I raised to N multiplied by 1 plus I raised to negative m. So you can see this cash flow, this is the cash flow or of an example of a deferred annuity. And for the next slide, we'll be discussing what does the variables here means. So P, again, that is equivalent to the value or sum of money at present. F is the value or sum of money at some future time. A is the series of periodic equal amount of payments. I is the interest rate per interest period. N is the number of interest periods or number of equal payments. And M is the number of interest periods where there is no payment made. So that is our formula. So for example, we have here the cash flow. This is an example of a cash flow and we are looking for the present worth. So as you can see from here, there are 3 years that has no payments made. So that is equal to this. And there are 5N or 5 number of payments. And that is equivalent to this one. So meaning to say P1, in order for us to get the P1, we have 1 plus I raised to N minus 1 all over 1 plus I raised to N times I. N again is the number of payments made. So meaning to say there are 5 payments made in this example. And there are 3, M is our 3 here. There are 3 years or 3 payments that, 3 periods that has no payments made. So that is how we get the present worth. We also have the future worth. This is just an example of a future worth cash flow. So as you can see, we have 6 periods of payments made. So that is equal to this. And there are 4 periods that there are no payments made. So that is the 4. So in order for us to get the future worth, we have to get the future first, or the F, and then we can already get the F sub 2. So first we have here an example. A boy is entitled of 10 yearly endowments of 30,000 pesos each starting at the end of 11th year. So as you can see from this one, so meaning to say from 0 to 10 there are no payments made, or 0 to 10 years there are no payments made, and from 11 to 20th year there are 30,000 payments made. Using an interest rate of 8% compounded annually, what is the value of this endowment now? So meaning to say we are looking for the P, or what is the value of this after we have made several payments. So from the example, we have N is our number of payments, which is 10. And the annual payment that we are paying is 30,000. We also have the interest rate, or the I, which is equivalent to 0.08. So from here there are 10 payments that are not there are 10 periods that has no payment, so that is our M. So make to say our M is equivalent to 10. Now from the formula that we had earlier, P is equivalent to A over I times 1 plus I raised to N minus I all over 1 plus I raised to N multiplied by our 1 plus I raised to negative M. So again, we have A as 30,000. That is divided by our interest, which is 0.08, multiplied by 1 plus 0.08 raised to N, which is 10 minus 1, all over 1 plus 0.08 raised to 10 multiplied by 1 plus 0.08 raised to m, which is 10. So now this is equivalent to, if you try to calculate that one, that is equivalent to 93,241.98. So this is now our final answer, or the final present worth. If you total this one, if you total the payments or in the yearly endowments, so you have 93,241. That is including the interest. Next one, next example we have here. A man invested 100,000 pesos every end of the year for 10 years. 100,000, then waited for another 10 years for his money to grow. If his investments earned 8% after tax compounded annually, what would be the sum of his investments and earnings at the end of 20th year in pesos? So in this case, again, we have A, that is our annual payment, that is 100,000. We have N as 10 years, and we have I, or our interest, as 0.08. But as you can see from here, there are payments made since the start of the year. Now, it says that when there are payments made from the start of the year, you need to count for the M, for the value of our M, you need to count this one, the start of the year, until the last one. So meaning to say, since this is 10 and another 10 years, so that is just equivalent to 20. So from here we have, we are looking for the sum of his investments. So we have to find our F. So F again is equivalent to the formula A over I multiplied by 1 plus I raised to n minus 1 all over 1 plus I raised to n, that is multiplied by, no, that is already this one. And this should be, sorry, this should be only A. So we have this formula. So let's try to substitute this one first. This is just the F. We also need to find the S, or from the discussion earlier, that is F2. So A is 100,000 multiplied by 1 plus I, which is 0.08, raised to n, that is 10, minus 1 all over 1 plus 0.08 raised to 10. So that this is equivalent to, I'm sorry, this should still be multiplied by I. So we have times 0.08. So now the equivalent value of this one, if you try to calculate this one, this is equivalent to 671,008 pesos point 14 centavos. So that is for the F. Now we still need to find the sum of the money after 20th year. So meaning to say, we have F sub 2 is equivalent to F times 1 plus I raised to M. So we have 671 and 8 pesos point 14 centavos multiplied by 1 plus 0.08 raised to our M, which is 20. So we have the final answer as equivalent to 3,127,540.18 centavos. So this is now our final answer. Next example, we have a parent on the day that child is born wishes to determine what lump sum would have to be paid into an account bearing interest of 5% compounded annually in order to withdraw 20,000 pesos each on the child's 18th, 19th, 20th, and 21st. So this should be ST, 21st birthday. And again, that is 20,000 and 5%. So again, we have A as equivalent to 20,000 since that is the amount that we need to withdraw every year from 18 to 21 years. And we have we have our I, or the interest, which is 0.05. We also have our N. Since we are withdrawing this one, 18, 19, 20, and 21, that is equivalent to equal number of withdrawals. So that is N. So now we are looking for we need to determine the lump sum that we have to pay into an account, meaning to say we need to find the P, or the principal amount that we need to deposit to an account so that we can get 20,000 each year. So we have now the formula P is equivalent to A over I. This is the formula of a deferred annuity. So we have 1 plus 0. Let's just write the formula first. So we have 1 plus I raised to n minus 1 all over 1 plus I raised to n multiplied by 1 plus I raised to negative m. So again, this is the formula of our deferred annuity. So just substituting the values that we have 20,000 as our A, and our I is 0.05. Multiply that by 1 plus 0.05 raised to n, which is 4, minus 1 all over 1 plus 0.05 raised to 4, and that is multiplied by 1 plus 0.05. And our m here is, since again from the child is born, so that is from 0 to 17 years. Since from 0 to 17 years there are no annual withdrawal that is made, so meaning to say our m is 17. So calculating this one, you'll get the result of, that is equivalent to 30,941.73. So meaning to say we need to deposit 30,941.73 into an account in order for us to withdraw 20,000 for the 18th, 19th, 20th, and the 21st birthday of the child. So that is the answer, the final answer for our problem. Next is, we have here another example. An asphalt road requires no upkeep until the end of 2 years, when 60,000 pesos will be needed for repairs. After this, 90,000 pesos will be needed for repairs at the end of each year for the next 5 years. Then 120,000 pesos at the end of each year for the next 5 years. If money is worth 14% compounded annually, what was the equivalent uniform annual cost for the 12-year period? So if we try to draw this one into a cash flow, in a deferred cash flow, we have from until 12 periods, right? So we have, this is the 0, this is 1, which we have to pay 60K, 2 is 60K, 1 and 2. In the next 5 years, that is 90K. This one as well, 2, 4, 5. So these are 90K each. And for the next 5 years, we have 120K each. 2, 3, 4, 5. So we have 120K. So this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is um, what are needed, what are the money needed for the 12-year period. Now, what we need to check is what will be the annual, what will be the total or equal uniform annual cost for the 12-year period if we don't do this one, the 60K, 90K. What if we total this one? What if the yearly amount should be total? What will be the money or the annual cost? So from this, we need to find first the our present worth at 60K, at 90K, and 120,000 pesos. So meaning to say, if you sum up the money that was that costed for this one, 90K, 60K, and 120K, we can get the present amount. Then let's do this one first. So we have the I as 14%. So meaning to say I is equivalent to 0.14. And our from the 60K, from the first 2 years, there is no unkeep made. So meaning to say we can use the formula of our compound interest. So we have P is equivalent to F times 60K. F is our 60K, and we have, let's just write the formula first. So we have, this is the formula of a compound interest, 1 plus I raised to negative n, plus the formula of our present worth, which is for the deferred annuity, which is A over I, multiplied by 1 plus I raised to n minus 1 all over 1 plus I raised to n times 1 plus I raised to negative m. Next is, this is for the 90K. Next is for the 120K. So we have A raised to I, the same formula. We have 1 plus I raised to n minus 1 all over 1 plus I raised to n, 1 plus I raised to negative m. So from this, let's try to substitute first for the 60K. So we have P is equivalent to our F is 60K. So that is 60,000 times 1 plus our interest, which is 0.14, raised to number of payments. So that is 2. So this one is 2. Plus, for the 90K, we have 90. I'll just write 90K. And our I is 0.14 multiplied by 1 plus I, 0.14, raised to n, which is, there are 5 number of payments, right, for 90K. So we have minus 1. That is all over 1 plus 0.14 raised to 5 multiplied by 1 plus 0.14 raised to negative m. Now, what is the number of our m here? So we'll start from here. We have 1 and 2 because that is where there are no 90K payments made. So from here, we have to use 2. The next one is for the 120K, the same process as the 90K. So we have 120K all over 0.14 multiplied by 1 plus 0.14 raised to 5. Since there are 5 payments made for 120,000 minus 1 all over 1 plus 0.14 raised to 5. That is multiplied by 1 plus 0.14. And for the number of M now, we already have, since that is for 120K, so we just have 7 payments or 7 periods that has no payments for 120K. So what we have here is 7. So if you try to total this one, each for the P for 60K, that is equivalent to 46,168.05, plus the 90K, that is 237 and 747 pesos point 99 centavos, plus we have 164 and 638 pesos point 47 centavos for the 120K. So if you total this one, we have 448,554.51 pesos. That is for the present worth. Now, since our goal again is we need to find the equivalent uniform annual cost of this one, if this is not how the way we pay or how the way we spend for the road repair. What if we allocate yearly budget, annual and equal payment or cost for the road repair? So from that, we can use the formula of our present worth in the deferred annuity. So we have P is equivalent to A over I multiplied by 1 plus I raised to n minus 1 all over 1 plus I raised to n. I'm sorry, this is the formula for the ordinary annuity since payment is made at the end of the year. So this is again the formula of our ordinary annuity. So substituting the values, we have P is equivalent to 448,554.51, and our A is unknown since this is our goal to look for the equivalent annual cost, yearly annual cost. So we have our I as 0.14 and multiply that by 1 plus 0.14 raised to n, which is equivalent to 12, that is in 12-year period, minus 1 all over 1 plus 0.14 raised to 12. So A now is equivalent to 79,245.82. So meaning to say, this cash flow here can also be replaced by a yearly amount of 79,245 each. So this one is also 79,000, this one as well. And each year there are equivalent number of total cost, which is 79,245, rather than creating this one 120K for 5 years, 90K for 5 years, and 60K for 2 years. Instead of doing that, we can have our annual cost of 79,245.82. So that's it for this video. I hope you learned something from this video, and I'll see you on the next videos. Thank you, and I hope you don't forget to like and subscribe.